Within today, we want to discuss about quantitative and qualitative analysis, and we want to see, how we can apply descriptive statistics and exploratory data analysis on data, and we want to discuss what they are and why they are important. So, uh, the first thing is we have to find out the difference between analytics and analysis, and this is really misunderstanding sometimes. If we are talking about data analytics, it means we are talking about data pipeline. So data pipeline means we have to collect data like from databases, from sensors, from cloud, from any source that you want to get those sort of data. So data analytics means create a data pipeline by collecting data, storing data, managing data, cleaning data, transferring data, and at the end to visualize your result. So, but when we are talking about data analysis is just talking about, how to work with data, how to clean data, how to prepare data, how to transform data, how to model data. So the big difference between data analytics and data analysis is we ignore data collection and data storage in data analysis. We assume that they are already there, they are already on board. We just need to do analysis. So for today also we want to discuss about data analysis because data can come from different sources, databases, cloud, from real time pipelines, from cloud, from let's say big data channels. You can collect data from everywhere. That the discussion for today is not about how to collect those data. The discussion is we have data and we want to see how to analyze data. So descriptive analysis or descriptive statistic is a technique, let's say, is a way that you can get insight out of data. So because we usually have data that's not really understandable. If you open Excel file, including data inside, these are raw data that we cannot make any decision on raw data until you have analysis on data, until you have visualization on data, right? Because humans or decision makers need, additional information, additional knowledge out of raw data to be able to decide, to be able to use data for modeling and so on. So there is a method in Python we call describe, and describe is going to give you well enough information about data, and we will practice with this method. So this is the main idea of descriptive analysis or descriptive statistics. So it means let's say this is raw data, and this is really small data, small size data, like 16, 18 or 17 rows with 4 columns. By the way, even these small data, we cannot get well enough information out of that if we open this file every day. So just checking, there are several ages: 36, 22, 61, 88. There are like favorite ice cream flavor and so on. So at the first instance they are not really helpful. If you can convert this raw data to a piece of information like how many male and female, how to analyze this flavor, or even find out the average of ages, within this data set. These sort of analysis, these sort of statistics help, let's say humans, or let's say help decision makers, help, managers, help data scientists to get well enough information out of that raw data, and then they can take a decision. So the whole topic, the whole idea of data analysis is, this conversion, from this raw data to this statistic way. So, and these are really necessary skill sets that we need to have it. And this is what exactly we call descriptive analysis, right? If you but we have another keyword we call exploratory data analysis, or we call it EDA. So EDA is also analysis approach, but the difference is using graphics, using statistical graphics. So if you are able to visualize your information, your analysis through, let's say, numerical representation, we call it descriptive statistics. If you can visualize your finding using graphics, using plots, using like matplotlib, seaboard, plotly, bokeh, and I mean anything like graphic. If you use graphic and plots, then you can name it exploratory data analysis. You can call it EDA. So this is just, difference of two keywords: EDA, exploratory data analysis, and let's say here descriptive analysis. So for both of them, even as you can see here, we use plots, like this is a plot and this is a plot, right? Also for these plots, because they are based on descriptive statistic or descriptive analysis. But for these two, let's say for these bunch of visualization using graphs, there is a new keyword that they call EDA, just new keywords, but both of them, do the same job. So yeah, let's move on. Before any analysis, we need to understand what sort of data we do have. So we usually have two types of data: qualitative data and quantitative data. So qualitative data, or let's say qualitative observation, is talking about characteristics and the quality of data, right? Of, a data set, or even the column or data, whatever. So, or use or senses to observe the result: sight, smell, touch. We call them qualitative data or qualitative observation, like the color, the size, the texture, right? These are qualitative approaches. For instance, if you say school is hot, so hot is qualitative observation. Blue is a color, so this is qualitative observation. And at the other side, we have quantitative observations, that it's talking about measurement. It's talking about, let's say these are talking about numbers. So qualitative talks about characteristics, that they are not numbered. It's a simple word, there is no number. But quantitative, there is a number, means there is a value, either integer or, decimal. Like there is one shirt, so one is quantitative. So it is 91 degree, so this is quantitative. So if you want to represent data qualitative, you can say it is hot. But if you want to express it or interpret it with, quantitative observation, you can use number, right? And this is the way you can you can separate qualitative and quantitative. So for data analysis, we need quantitative, right? So because data analysis is working with values, not with textual input or textual output. So if you have a data, like let's say a few columns include this qualitative, like hot, blue, male, female, and so on, there are two options. First option is convert, those qualitative observation to quantitative. For instance, if you have this male and female, since this, gender is only male and female, for instance, you can add male 0 and you can add female 1. In this case, you can convert, those textual inputs to numerical input. even for these, these ones, if there is, you just need to take into consideration one important condition. If there is a finite values like female and male and female, there are just two values, right? This is finite. If there is a finite values, then you can convert qualitative to quantitative. But if there is no finite, means you cannot have the let's say the boundary, like a minimum value and the maximum value, or minimum textual input and maximum textual input, then it's really tough, it's really difficult to convert them to quantitative. In this case, you have to ignore, you have to remove those data that they are not, they are not relevant or they are not useful for data analysis. So to conclude, we need data to be in numerical format. So quantitative observation. So for quantitative, we have two types of data that we call discrete and continuous. So it's simple, because if you can count your data, then we call it discrete, like this one: number of children, number of languages, number of people. So can you see that there are 4 children? I know 2 languages, there are 100 people. So we can count them. But continuous data have infinite number, right? And it's better to say we cannot count them, right? We cannot count them, like height of children. So the time to wake up in the morning, speed of the train. So can you see that both of them are numbers, discrete and continuous? But discrete is, let's say this is integer values. These are integer value, but here they are double values, or let's say float values. So if you face with any double or float values, you have to consider it as continuous. If you face within any integer value, we have to consider it discrete data. This is like a flag, to understand discrete and continuous. So yeah, these are the things. So to conclude these 3 slides, we have qualitative and quantitative data. Qualitative is about characteristic of data, but quantitative is about, the number of data, talking about quantity, right? This slide. And as I said, we need data to be in quantitative format. So to be able to analyze them, to be able to count them, and we will check, and also we will see the techniques that you will understand why we need quantitatives. So, and then we have 2 types of quantitative data, discrete and continuous, and these are just for separating these 2 typical type of data. And you may hear about population and sample. So let's say we want to measure the height of all students in UEL. So if you have access to all students, so then we call it population, means we have access to all, samples. But if you have no access to all population, that this is more logical, it does make sense to do not access to all, to all students at one day, or let's say within a week. So in this case, you can take a sample. Sample means a copy of population. And then, like, for instance, you can take 10% of student from computing, 10% of student in art, 5% of student from engineering, and so on. You can take a sample, and then we can work with those samples. And whatever we conclude from sample, then we can expand it to population. So these are also most important keywords. So let's do a start, the techniques. Let's see what sort of techniques we need to learn. So one typical techniques, let's say one typical category of analysis called numerical measures for data representation, or measures of location. So there are 5 methods that they are frequently used for descriptive analysis or descriptive statistics. So like averaging or mean, median, mode, percentile, and quartile. Let's consider one by one. So let's say we have data. Let's say we have hourly traffic counts at 3 intersections. So these are 3 intersections, and these are the number of cars, passed over these intersections. So let's say, for instance, at 6 a.m., there are 61 cars passed over intersection 1, 132 cars passed over intersection 2, and 186 from intersection 3. So, I mean, this data we call it raw data, right? This is data, we have it. But with this typical, information about intersections and the hour, we really cannot take well enough information. What sort of decision we can take out, out of this raw data. This is the question that we have to answer using data analysis. So I used dictionary to declare this traffic, so intersection 1, 2, and 3, and then I convert this data to data frame. So guys, data frame is, is a table format, right? This is a table format having rows and columns. So the best way of analysis is converting your data with any format like dictionary to table format. So how to do that? You have to import pandas library, right? After that, pandas library has method called data frame. So data frames ask, so what is your data? I'm saying my data is traffic, is here, traffic. So what about columns? I'm telling to data frame that these are my columns. It means get each column intersection 1, and these are the values, right? These are the values. So get the values as first column. So intersection 2, get the values as intersection 2, and so on. Make sure to have the same naming, like int dot space 3 should be int dot space 3, right? Otherwise, it gives you error. It says there is no intersection 3. So at the end, if you type, this variable, then you can get, this visualization in your Python editor, using Jupyter Notebook. So we have this data. Let's see what sort of information we can get out of this data. So, if you want to trust on your eyes, like intersection 1, you can see, this is the minimum traffic at 1 a.m. and the maximum traffic is at 7 p.m., right? So with eyes, you can trust on your eyes to get, let's say a few piece of information, to understand this data. But let's move on to see how we can use these techniques to do it simply. So first techniques we call mean. It's called is the measure of central value, average, right? Means to calculate the average. So how to calculate average is the summation or the sum of the set of numbers divided by the number of numbers. So if we have here 10 items, 1, 2, 5, 4, you just need to do summation and divided by the number of items. Here we have 10 items, or let's say 10 numbers. So then this is the average value, 6.4. So how to apply it on data frame? So if we say df underline traffic, guys, df underline traffic is a data frame that we made it here, right? We made it here. So data frame has the method called mean. So if you say data frame dot mean, it's going to calculate averaging over each column. it's going to say intersection 1, which is first column, the average value is 32. Average value for intersection 2 is 46.5, and so on. So this is the average. So fair enough. And if you want to consider only averaging on, let's say, one column, so in this case you have to call, data frame, and then you have to say which column, intersection 1, and then calculate mean. And this is my mistake, there is only one n, not two n. So mean, and then it's going to say 32. You can apply on one column, or if you want to apply on two columns, like intersection 2 and 3, you can put them as an input here, and it's going to calculate only average of two columns. And let's say you want to calculate the average of this column, this row, right? I want to calculate the average value of intersections at 1 a.m. means 7 plus 13, 20, 20 plus 11 is 31 divided by 3. We want to calculate this average. How to do so? You have to use iLoc, means index location. So which location? Location 1. So location 1 is this one, right? Because indexing start from 0. So 0 index means first row, index 1 means second row. It means I want to calculate the average of values in second row. So how to do so? You have to use index 1. So with these ways you can have column calculations, and with this iLoc you can have row calculation. Column, why is really bad handwriting? Oh my god. Okay, no worries. Column. So using column, using iLoc, or means index location for row calculation, and then dot mean is going to calculate the average. So we have median. Median means the most central item, right? So how to do so? First of all, you have to put your data in ascending format, starting, for instance, in this case we have 1, 2, 4, 6, and so on. And then you have to exactly find the middle value. So there are 4 items left side, 4 items right side, and this is the middle one, right? 9 is we call it median. So if we have even number of values, then you have to calculate the average of 2 middle values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Since there are 10, you have to get out 4 values left side, 4 values right side, and there are 2 values in the middle, right? If you consider 9 in the left side, then it would be here 5 numbers and here is 4 numbers. So this is not median. Median means the left side and right side should be the same number of values. So 9 and 10, 9 plus 10 divided by 2 would be 9.5. So we call it median. And simply you can do like mean, just call your data frame, and then dot median is going to tell you what is the median value. So if there is decimal, means how many values we have here? We have 23. Since we have 23 values, right? Oh, sorry, we have 24 values, and that's the reason it's going to consider median. And if you want to use median for a specific row, again you have to use iLoc. For instance, you want to find a median, I don't know, for this one, but since it's simple to find it, the median is 58, is exactly the median value for this row. For this row, what is median for this row? You have to put it firstly in ascending order. It is 10, 32, and 47, and then 32 would be median, for this row. So how to do so? Like mean, you have to use iLoc and then put like 20 means row 21, and then dot median. So simple. And mode. Mode is the most frequently occurring number in a distribution. So what does it mean? It means if we have these values, right, it's going to find out the most frequently occurring number. Here we have 3, 7. Can you see that? There are 3 numbers with 7. So 7 is the mode. So how to calculate mode in within this data? So if you if you say df and then this column dot mode, it's going to go through first column and find the most frequently occurring number. It says it's 11, so we can check that 11, 1, 11, 2, 11, 3 11s, right? There are 3 11s in first column, and this is the most happening or most occurring data at intersection 1. So if you see intersection 3 mode, it returns 2 values, 9 and 15. So 9, 1, 2, there are 2 9s. What about 15? There are 2 15s. Can you see that? So since there are the same number of occurrences, then we have 2 modes, 9 and 15. So, and if you use this one, df.mode, so it's going to calculate mode for 3 columns. So 3 columns. But maybe you want to ask what are these null values? So these are because of this intersection 2. So if you go through intersection 2, and there are 2 number 9, it would be 2 number 13 and 2 number 12, right? One is here and one is here, and also 36, right? If you find there is one and there is another one, right? So since there are 4 values with 2 occurrences, so it's going to write it down here. But in intersection 1, we have only 1 value. Since you are putting them all together in one table, that's the reason it says we have nothing, for this, and for this, right? And this is also for intersection 3. Since we have 2 values, it says we have nothing for these 2 rows, and that's the reason you see null values, for these inputs. So you may ask why we need these 3 averaging techniques: median, mode, and median, mode, and mean. So it depends, guys. Sometimes you have a case study that there are, there is a duplication. So maybe you want to consider which number is the most duplicated, So in this case, you can use mode. So median means sometimes you are not going to consider the average. So maybe average is not really good parameter to calculate. That I want to explain why sometimes we don't need. So you can find which value is exactly the central value, and then you can exactly find the central value. So, but when we can use these 3? So here we have this sort of input: skewness and averaging. So as you can see, this one. If mode is less than median and median is less than mean, so we call it positive skew, right? And right skewed means because of this one, right skewed. And since the right side is the positive numbers and here is negative number, negative and positive number, negative and positive. So this is like this, this is X and Y, right? Which is minus X, this side, and X this side, means positive and negative. So what does it mean? So guys, we said mode is, where is that? Mode is the most frequently occurring number. So if mode is less than median, and median is less than mean. So guys, this shape shows the most data are collecting here, are distributing here, and we do have less value here. So we call it the shape of the data. So, but here, if mode is greater than median and median is greater than mean, then we can see the most data are collecting, distributing here in this peak, right? You know, in this long peak. And then by going to the left side, there would be, you know, less values. But if mean, median, and mode, they are somehow equal to each other, and then we call it, you know, symmetrical distribution. We call it normal distribution. Means we do have, you know, somehow the same number of items, you know, in the left hand side and the right hand side. So why we need that? It helps us to understand how data are distributed, you know, where they have been collected. And also it helps to find outliers. Outliers means far data. Outliers means those data that they are separate from the main distribution. So if here is the main distribution of data, then those data here we can consider them as outlier, as we call them far data, or also we can consider them as noise. So why we call it noise? Because if we have data that they are far from normality, right, that we can consider it, you know, unnecessary data. For instance, let's say uh, we want to calculate the height of student, right? So if we have, let's say, uh, if the minimum height is, guys, this is just example. I'm not going to take any advantage of this example. This is just for example. So if we have student like 100 with 100 centimeter by, I mean, as a height, and if we have someone with 220 means 2 meters, 2 meters and 20 centimeter is, you know, is really tall, and he or she is really short. But if we have few others, the other, let's say other student, they take like, and also let's say the average height is 80, 70 centimeter, right? Uh, if you find out the most, you know, students, the height of student are here, right? And like we have one student here, or maybe two students here, right? But we don't have anyone with 100 centimeters. As you can see, this distribution is something like this, right? So since this is going to be short, let's say it's going to be uh, shorter, I mean this distribution, we call them, you know, we call them outliers. Why they're outliers? Because they are far from normalities. These are the normalities. Normalities means the most data are collecting in the same, you know, in the same within the same space, you know, like these values, you know, these values. So we call this one, you know, outlier. So if we have someone that his or her height is 220 centimeter, we flag him or her as a tall person, right? But sometimes we need that value to be considered within data for analysis, because we cannot ignore taller guys. We have to consider them, but it's good to flag them to find out how many values are outliers. So, and yeah, these typical shapes help to find, you know, those values. Let's move on, you know, one by one to understand, you know, these examples. So how to calculate skewness, you know, to find out how data distributed. So this is the way that you can calculate skewness. If you want to calculate it using math, it says get each value, subtract it with the average of the value, and then power it by 3, and then do summation. And here it says for each value, subtract with average, power it by 2, and then calculate the summation, and then calculate, this power, and then at the end multiply it by square n, and then you can get skewness. So if skewness is negative, the data are spread out more to the right. So you can see here. So as you can see, we call it negative skewness, right? Because this one is going to be through the negative side. So if you find the negative value for skewness, means it's negatively skewed, and we call it left skewed because this skewness is in the left side, right? But if your calculation is positive, if you calculated your values, you got positive skewness, means your data is right skewed because of this tail, and we call it positive skewed. So, but let's consider this example. So, yeah, if skewness is, this is like calculating rough calculation. It's not exact calculation. It says if it's positive, it's called positively skewed, moderately skewed. If it's less than -1 or greater than 1, means it's highly skewed. So highly skewed means like your data is long head, and maybe very long skew. So this long skew is not really good to have it in data, and we will discuss why it's not really good. So let's take this example. It says suppose we have house values ranging from 100, this is 100K, and this is, let's say, 1 million K, right? So with the average, so average is 500K. So if the peak of the distribution was left of the average, means the peak is here, right? The peak is here, something like this. So what we can consider, how we can analyze the analysis is the most, I guess I mentioned it here. It would means that many houses were being sold for less than the average value, right? Because the most, sold houses are here in the left hand side. So means there are few houses, sold, 1 million K or, less than 1 million K. But in reverse, if you have it here, 100 and, or let me do it exactly in the same. So, but if your skewness is like from right side here, right? And then if it's here, means the houses were being sold for more than average, means, they have been sold expensive, because they are here. So with just, simple calculation, let's say if you are working for real estate, for agency, working with like I'm thinking about the website that's working on this. So I forget the name of the agency. So let's say there is agency, they have more than, let's say, 20K or 20,000 of houses with the range of values, but they don't know that how they sold, the houses. Is it undervalued or overvalued? So how to do so? Simply calculate skewness, and then you can find out the houses were being sold, undervalued or overvalued. So simple to calculate. So if you use that skew, you can see if you use that skew, it's going to give you the skewness. So since these are more than 1, so if we consider here, it says if skew is less than -1 or greater than 1 is highly skewed. So what does it mean? So skewed for first intersection. So for first intersection means, so the first intersection is 1.7, means, let me double check here, highly skewed. So means we have something here, but the highly skewed means this is long, right? This is for intersection 1. Why this is long? if you have a look into data here, so if you see we have, like, can you see 114? Guys, is a bit far from other values. 114. So, and then before 114, which value is it? Is it 75, right? So it means there is one value 140. Oh, sorry, 114. 100. Yeah, 114, and then there is one is 75, something like this, and the rest are, somehow here, and we do call them, outliers. Means they are far from no normalities. So you, as a data analyzer, as a data scientist, in terms of your case study, you have to decide to ignore them, to remove them from data, or consider it within your analysis. These are really up to the case study to remove them for analysis or keep them for analysis. Because if you keep them for analysis, they want to bring, momentum, means they want to bring maybe not really trustable result, because the most values are here. Just because of these two outliers, it's gonna to change, your calculations. By the way, it needs experience to see, when to keep them and when to ignore them, and so on. So you can calculate this skewness, for all intersection, or you can calculate, for only, one column. And yeah, and this is the way you can print out, because yeah, you can print out because this is long decimal part. You can see that here is the long decimal. If you want to make a short decimal, you just need to take, this printout format that we practice at week 1 and at week 2, not week 1. So we practice at week 2 to how to format output. So it means to keep 4 decimals, and this is what exactly we see, 4 decimals, and then calculate skewness. So yeah, and then kurtosis. So kurtosis is going to talk about these how data is is talking about the flatness of data, means how data is flattened. So if you get the kurtosis, greater than 0, means these tails, these are short tails, means this head is a long head, right? If it's less than 0, means we have this long skewness. We have these long tails and the short head. This head is short. And but we usually would like to have this normality. This black one means a normal distribution. Normal distribution means we have minimum number of outliers, and the most data are distributing or collecting, close to each other. That's the most important and the most, uh, not frequently happening data set, because in real case studies, the most data having really ugly distribution, like this one, is coming this one and then going like this one, right? This is really bad distribution. If you have something like this, you have to consider these data here, right? You have to decide to how to work with them. Guys, uh, you may heard about outlier or noise removal techniques. This is a unique topic that, data analyzer needs that. So I can guarantee you guys, the most data analyzer working industry, they have no idea about outlier removal. They don't know what is outlier, because they have no this this set of skill sets, and they usually, they are struggling with this sort of information. And since they manager also, they are not educated in data analysis. They don't know what their employees do, because they trust their employees, about having skill set of data analysis. In this case, if your line manager, if your decision makers in your company, they have no idea about these typical techniques, then the result coming out of data would be, let's say, would be not really useful. Maybe it's not going to project data, to the information, to the exact information, or whatever you need. Maybe it can change, the advertisement policy. Maybe you want to consider a data set. You want to get, averaging result, and based on those averaging results, your line manager is gonna to decide about, let's say, about the advertisement policy, or about, selling policy. So if your results are not really projecting your actual data, then the decision maker is going to make a wrong decision. So that's the reason the most big companies, right, they have well-educated data scientists, or let's say they have well-educated with, let's say, well skill sets on data analysis. So these are really important. Having more analysis experience, then you can make more money on that, and then you can take, like data manager skill. You can get, senior data engineer, senior data engineer job, and so on. Otherwise, if your knowledge, if your skill set on data analysis is not really, let's say, is under the threshold. Under the threshold means you ignore these skill sets. So then you usually should find, like entry-level jobs. But if you have these skill sets, then you can, go ahead with more advanced jobs, and let's say well-paid jobs. So, and these are data. What is the time? 11. So let's finish these courtesies, and then we can have a short break. So we calculated courtesies for intersection 1 is 3.5. So 3.5, can you see that is larger than 0? If it's really large, and it's usually the largest value is somehow +5, -5, or sometimes some other sources says it's usually between +3 and -3. It's somehow, right? These are sorry, +5. So it means this is the maximum value for courtesies. This is the minimum. So since this is 3.5, means at intersection 1, so this is 3.5. So means we have a long head. So it's going to be long head. So what about tails? So we can check at the same time, we can check skewness. So skewness is 1.7. Means it's right skewed. Means this is long and right skewed. So long. So we are happy for long, because if it's long means there are many, values here, and there is a few values. So if it's long, so means we do happy because we have more data compacting, in this area, and we do have less outliers. So this is really nice data distribution. And then for few data, you can decide to how to keep them. But before how to decide about, these outliers, this is really, let's say, additional skill set you may need. And you need to understand how data has been distributed. Guys, we as a data scientist, we have to talk with data. We have to speak with data, right? And then apply, the bunch of techniques you may need that. So we could find data shape, that how data has been distributed. And let's say if your kurtosis is less than 0, this is the, this is the worst data data distribution. If you get something like this red one, means you have to maybe discuss with your line manager to say data is not really well distributed, and there are a range of values and they are far from each other. Let's say uh, let's say about the height of a student that I mentioned. If you have this 100 centimeter and if you have here 200 centimeter, if data are distributing, let's say not in the organized way like this one. So as you can see, data is everywhere, within this minimum and maximum. So this is the worst distribution. So in this case, what we have to do, maybe you need to collect more data till to shape data somewhere. Maybe adding more observation can help you to add, this way. So now is much better than, this red one. So just about the distribution of data, the shape of the data, to understand how data has been distributed. So in terms of how the tail and how the head is for a data, and it helps to understand, where is outliers, where is the actual collection of data, and so on. So, and also we discuss about averaging techniques, mean, mode, median, and now we want to consider other sort of methods for data analysis. So one of them we call percentiles. So percentile provides information about how the data are spread over the interval from the smallest value to the largest value. So let's consider to see how to calculate. So let's say this is the data. So let's say I have this data. I want to calculate 25th and 80th percentiles. Let's see what does it mean, and then by this example we can understand. So to calculate percentile, the first task is arrange data in ascending order. So we did here, we sort data. Number one, sort data from, in the ascending order. Okay, great. So second one is compute index, the position of the P's percentile. So P divided by 100 and then multiply by n. P is the percentile value that we want to consider. So here I want to calculate 25th percentile, means 25 divided by 100 multiply by the number of values. There are 10 values, right? There are 10 values. The answer is 2.5. So let's check here. So if I is not an integer, round it up. So great, it's not integer, we round it up. So it's 3. So then you have to find the position 3. So what is the position 3? 1, 2, 3. So position 3 is number 4. Means P3 is 4. What does it mean? It means, so the interpretation is important. It means 25% of items take number 4 or less than 4. So it's really obvious here. So can you see that there are 4 values taking number 4 or less than 4? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 values out of 10 values are number 4 or less than 4. This is exactly 25% of whole values. We call it 25th percentile. So I want to calculate 80th percentiles. It means I want to find out the value is occurring or less than value, the value or the less than that value occurring 80% of the items. So how to do so? Again, 80 divided by 100. This is the formula here, right? 80 divided by 100 multiplied by number of items. It's 8. So the result is the integer value. So if I is integer, the P's percentile is the average of the values in position I and I plus 1. So here we have to calculate. So it's P8, right? P8 is this one, right? This is 8. 1, 2, 3, 4, 5, 6, 7, 8. So it says the is the average of I and I plus 1. So 10 plus 11 divided by 2 is 10.5. So what does it mean? It means at least 80% of items take on a value of 10.5 or less. So also you can count them. So there are 8 values taking values, there are 8 values taking number 10.5 or less than that. So this is percentile, really interesting information that you can extract out of data. So another one is quartiles. So quartiles, there are specific percentiles. So if we say first quartile means 25th percentile. If we talk about second quartile means 50th percentile or median. So can you see, guys, median is really relevant to percentile and quartile. If we say third quartile means 75 percentile. These are like the specific percentiles. Okay, let's do practice here. So if you call your data frame quantile, if you use quantile, means you want to calculate quartiles. So dot quantiles, I want to calculate 25% of values, 50% and 75%. So if you see here, it says at intersection 1, there are 12.75 cars. This is average, right? 12, or let's say 13. Let's round it up. There are 25% of values are 13 or less than 13, right? So if you consider here, for instance, intersection 3, it says at 75%, means 75% of traffics are 90 cars or less than that. And if you consider this one, so you can interpret that. So with this typical information, you can understand how data has been distributed. So if you want to consider, like if you find out how data has been distributed using kurtosis and skewness, for instance, you find out your data is something like this, right? It's something like this. So with this set of information, and guys, here is mean, right? And here is mode. And here is my mistake. This is mean. This one is median. So it says 25% of values are 12.75 or less than. Maybe it's here just this part. And 50% are maximum 23. So you can find out these are 23 or less. And it says 75% are 42 and less. Maybe 42 is here, and then you can find here 75%. So 75% are within this. So maybe here we can call it outlier. So, and for any value greater than 42.25, you can consider it as an outlier because it's going to be the last 25% of occurrences. Or maybe you can increase that. Maybe you can calculate quantile of 90%, and then you can calculate the last 10% of data as outlier. So guys, these are really important. You just need to practice. It's really easy. I mean, once you practice, then this set of information would be really easy to understand. So it's done. This percentile, quartile. Let's move on with measure of variability. So variability is going to talk about variation or summary of differences within groups. So simple techniques: range, minimum, maximum, variance, standard deviation. So these are really simple. Let's do practice. So range means find the largest value and the smallest value, and then subtract it to find out what is the range between minimum and maximum. Somehow would be important. It depends on the case study. And if you need the range, then you can simply calculate largest and the smallest value and subtract together. So how to do so? So if you use that data frame dot minimum, it's going to give you the minimum value at each intersection. And if you use max, it's going to give you the maximum value for intersection. How to calculate range? Simple. Just say dot max subtract by dot min is going to give you the range. So for intersection 3, can you see that the range is really larger than these two? So what you can conclude there is more, maybe there would be more outliers. We don't know. We have to consider. So if there is this range 250 means there is a big gap between minimum and maximum values. So this is another information you can get out. So this is how we can visualize the result. If you want to have this nice visualization, what you need to do, you need to create a data frame. So guys, data frame, let's say, what I love with data frame is you can visualize the nice table. You can visualize, user-friendly table. So how to do so? It's better to firstly create a dictionary, right? With these keys. The key is minimum value and the value is, this calculation. The key is max and this is the calculation. And range is, this range that we calculated here. We have been calculated here. And then you can simply convert it to data frame. If you don't mention about columns, it's going to get these ones as the columns. So easy. So and then you can visualize simply the minimum one, the maximum ones, and the range. Nice visualization. So variance, guys, variance is the measure of how spread out a data set is. Variance is going to find out. So when we talk about percentile was going to consider the distribution from minimum and maximum, right? From minimum and maximum. But variance is also going to calculate spread out of data, but around the mean. So here we have average value or mean value, and it's going to find out how data has been distributed around the average. This is what exactly we needed from skewness and kurtosis, because skewness and kurtosis, they just give you, information about how the tail is long, how the head is long or short, about about these parts, this part, how long they are, or how tall this head is. So, but variance is going to exactly give you more information about the data around average. So, how to calculate? Since we are considering averaging, or let's say mean, the mean, right? The mean. Then you have to calculate the value, subtract with the average, power 2, and then do summation divided by n minus 1, and we call it variance, right? This is the symbol for variance. So if you use a sample, so you remember sample and population. So if you have access to all population, means you just need to change this one to n. But if you have a sample of population, you have to use n minus 1. And it's dependent which one you consider. The difference is only this minus 1. So since, guys, but in practice, we usually use a standard deviation. So standard deviation is the square root of the variance. So there is only one reason we do that, because of normality. So it means, because if you calculate variance can be a very big number, because your numbers would be like, the range of 10, 20, maybe you would have 1,000, maybe you have 1K, 1 million, and so on. So this is the big gap. This is a big range. So variance is going to generate the big number. So you can make it normalize. How to normalize? You can calculate, the square root of the variance to just simply I mean, simple, to decrease the size of the output. So this is the only difference. That's the reason we use standard deviation. So let's take this example to understand variance and standard deviation. So you and your friend have just measured the height of your dogs. So these are the height of dogs, 600 millimeter, 470, and so on. So now we want to calculate, I mean, the standard deviation. We want to consider how they are distributed around the average value. So first of all, we have to calculate the mean. So why we have to calculate the mean? Because of this one. I'm getting, this one because I have only 5 dogs. I want to calculate this result for 5 dogs. So means I have to calculate the average firstly, and then subtract each value with the average. So how to do so is here. This is the average, 394. So the average is this green color. Can you see that? This green line. This is the average, 394. So this dog is 260 millimeter, above the threshold, or let's say taller, and this is 76 millimeter taller, and this dog is minus 224, means shorter than, or it's down, so let's say the bottom of the threshold, something like that. And okay, this is about mean. Then you can calculate the variance. So how to calculate variance? You have to do this one. X, this one, the value subtract by average, then power 2, and then at the end divided by number of elements. So first dog is 600, right? 600 minus by 394, it's 206, power 2. You can do for second dog, third dog, and so on, divided by number of dogs. And can you see that, guys? The variance is really huge value, 21K. So to make it, within the range, you have to calculate the standard deviation. You just need to simply use this, square root. And it says the standard deviation is 147. But what does it mean? So how to interpret is here. This is a green color. This is the average. So average was 394. Okay, great. This is the average value. So this is standard deviation. We said that standard deviation is going to calculate how data are spreading around the mean. So means 147 upper than this, and 140 lower than this green color. So, and this, this part, we call it the standard deviation. How to interpret those dogs within this, within these distributions, we call them, they are dog with normal height. So since this is, it's, it's outside this, this threshold, we call it, this is outlier, means this is a data outside of the main distribution. So because this is the main distribution that we have been calculated. So also for this dog, since we calculated the shoulder, can you see that? We call it this one, this is outlier, and also this dog is outlier. So outlier means they are outside of main distribution. So what we can do, these are the sort of information you could generate out of raw data. So maybe after, getting advice from your manager, you can remove them from your analysis, or you can keep them within your analysis and then consider outlier removal techniques. Guys, these typical information really needs practice. Okay, we do practice, no worries. We have still time, and we do it by this Thursday. And this is the normal distribution. So this is the average, right? And this is standard deviation. So, and if you subtract average by standard deviation, we call it, this is first standard deviation, and we expect to have 68% of data collecting here in this part, and the rest would be somehow 27% of data would be here, that we call it 95%. And usually the rest of values means somehow 25% and 25% of value are here. So again, it's up to the case. You can ignore them as the outlier, you know, for analysis, or you can keep them considering outlier removal techniques. Perfect. This is about normal distribution. Again and again, guys, with practice, you can understand these things. And please, today is Monday. Till Thursday, we have still 4 days. And please go through this lecture note and practice it, you know, in Jupyter Notebook. So how to start? Start from first part here. Start from, where is that? Here, load data in Jupyter. So try to type, you know, these libraries and then, you know, define data, convert to data frame and print it out. And then you would have, you know, this data, and then start analyzing data, you know, by calculating mean. For instance, start firstly this one, get your result, then start this one, then do this one, then do that one, right? Do practice. And then you, I'm 100% sure you may have question, and then we can discuss on Thursday face-to-face tutorial session. And the last part is, I guess, is the last part. Okay, how to calculate variance and standard deviation? Simple. Dot var is going to calculate variance, but we usually don't use it. We usually use a standard deviation, right? So how to interpret, for instance, this one, 25. Let me see, do we have something here? No. Okay, is here, I need this one. So we said that standard deviation is talking about how data has been distributed around the mean. So for instance, for intersection 1, the average value is 32, right? Is average value. Okay, perfect. This one. Standard deviation is 25.75, right? This one. So if you do this calculation, guys, I'm doing this calculation. This calculation means mean plus standard deviation, mean subtract with standard deviation. So it's here, this calculation. And this is the result, 6.63. So here, for instance, is 6.63, right? And here is 57.37. So what does it mean? It means 68 of, here is 68% of data are within these values. How we could get them is here, right? 68% of values occurring here. So how to find out about the tail, and this head? So if you remember, the first intersection was highly skewed. What about head? Head was the long head. So it means we do have something like this. We have something here. This is the long one, you know, and then we had this one. So it was something like this. So then you can consider the right side as abnormal or outliers, but the left hand side we don't have outliers because of this shape. And the most data are collecting here, 68% of data collecting here. So guys, if you put this sort of information together, then you can easily find out data. So maybe you want to ask me that, okay, this data, why we need this sort of analysis over this data? So we can understand this data simply because there are only 24 rows. Guys, this is example. In the real case studies, you will face with a data set with more than 10K rows. So in this case, you cannot print out data like this. So you cannot print out 10K rows, like this. So how we can work with that? You have to know about this data analysis and then to be able to summarize. This is the keyword. You have to summarize your data into a meaningful way to get insight out of data. That's the reason. And the last part is this exploratory data analysis that I discussed with you. I've said that EDA is a technique that use statistical visualization. Means if you use plot, we can name it exploratory data analysis. One of the most important techniques we call 5-number summary. So what is that 5-number summary? 5-number summary means calculate minimum value, the lower quartile or first quartile, the median or second quartile, the upper quartile, and the maximum value. So the combination of these statistical method, we call it 5-number summary. So how to calculate? So if you want to calculate it by hand, manually, first of all, you have to put your data in the ascending order. For instance, I have these marks. These are data I have. Let's say these are the marks from last year. So first of all, we have to put them in the ascending order. So great, we did that in the ascending order. Then we have to find out so how to find minimum value is easy, right? The first one is the minimum value and the last one is the maximum value. So it's done. So what about median? So median, you just need to come through that, right, and find exactly the central value. So the central value is 78. So it's done. What about step 2 and step 4? How to calculate quartile 1 and quartile 3. Guys, I'm asking to do manually, to do on the paper. So if you want to calculate it on the paper for quartile 1 and quartile 3, what we have to do? You have to divide your data. So this one is the central value. So for the left-hand side, we can calculate the Q1, and for the right one, you can calculate the Q3, means quartile 3. So for the left side, the middle value is 75. For the right one, the middle value is 89. And this is the nice visualization. This is the minimum value, maximum value. This is the median value. This is first quartile. This is the third quartile. So means here is 25% of value, 50% of value, 75% of value. So guys, with this nice visualization, you can understand 25% of values are between 89 and 99. So 25% of values are between 48 and 75. So can you see that this is this is a big gap, right? But the minimum values are here, just 25% of values. And also the median, exactly the central value is 78. So maybe it can be a nice, mark distribution and so on. This is, another technique that you can extract information out of data. So how to use it with Python? So for 5-number summary, so as I said, minimum value, maximum value, and then here you have to calculate the quantile of 25, 50, and 75. So we put them all together in this variable called quartile. This is just for column 1, intersection 1. And then quartile I look. So once you calculate this one, quartile will give you 3 values. So first index is 25%, second index, 50%, and third index 75%, and you can simply find out the 5-number summary. So this is the numerical result. How to plot them? Plot is here. So simply use df underline traffic dot box plot. So box plot is going to visualize these 5-number summary, simply these 5-number summary. So maybe you want to ask, what are these, points? Guys, these are outliers. These are what exactly we discussed. It says if we ignore this one single item, then this is the box plot. If we ignore these 3 values, then these are the box plot. And if we have long, line like this, means we have to consider it a bit noisy, a bit, let's say a bit gap, between values and something like this. And if you use, Seaborn, if you remember from last week, I said Seaborn, visualize the nice visualization, as compared to Matplot. So this one is a bit, let's say, good looking as compared to this one. And somehow in the, I guess, slide 4 or 5, I said that you can use Describe to give you well enough information about the statistic parameters. If you use df underline traffic dot describe, it's going to give you, well enough information over 3 columns, like count, how many values there are, the mean, the averaging, standard deviation, minimum value, the 3 important quartiles, and the maximum values. Using Describe gives all these information together, right, in one single table. And yeah, that's it. I guess we are at the end of the session. Perfect. And this is, guys, this is like the roadmap. If you have data, right, before starting analysis, first of all, you have to understand data. So we do practice for coursework. So first of all, you have to understand data. For instance, if you have data about COVID-19, so before doing any analysis, before being in a rush, you have to see data description. What is the what are the features? What is the column? How many rows there are? About the type of the data, how many quantitative, how many qualitative there are, and so on. Afterwards, you have to decide about data pre-processing. Clean data, cleans the data, means remove outliers, keep outliers, remove missing values, and so on. Also, we will practice by next week about, data pre-processing. And then, yeah, you can go through analysis, then apply, averaging, apply percentile, quartile, and whatever you want. And then plots to visualize your findings. Really simple steps. You only need this step to do all together.